Hello everybody, this is Sanudas. Welcome to Geography with Sanu. In this video, we know about what is scale in geomorphology or what is geomorphological scale. So, geomorphological scales is a significant parameter in the interpretations of the landforms, development and landform characteristics of geomorphic systems. The geomorphic investigations requires the study of different geomorphic processes and related to the landforms of its spatial unit over a definite time span. The geomorphic scale very often used in geomorphological investigations. Geomorphological scale is an important unit through which we can simply say we can study the landforms evolutions throughout time. So, geomorphological scale are two types. One is time or temporal scale and another is spatial scale. So, what is time scale and temporal scale? Temporal scale or time scale is a term referring to the comparisons of made with respect to the passage of time. So, it is types of geomorphological scale which proposed that the landforms are studied in different time spans and they are in different time spans. So this is temporal scale. Temporal scale are different types of temporal scales. We can simply classify the temporal scale or time scale in three types. One is cyclic time scale, cyclic time or cyclic temporal scale, graded time, and another is steady time. So first is cyclic time. So cyclic time and which resolutions level is macro and time span is 10 lakh years, about 10 lakhs years, and its characteristics are few characteristics are landforms evolution related to the long time span. So this is a scale through which we can study the landforms in long time span, and evolutions of rate are very slow. So the landforms evolutions rate are very slow. In this cyclic time, the landforms are evaluated in very slow rate, and the evolutions rate of the landform is very slow, and decay equilibrium. So the example of this are cyclic time. The landforms example is delta formations. The delta are formed in very slow process. So it is an example of cyclic time. And another important temporal scale is graded time. So its resolutions level is meso resolutions level, and its time spans about 100 to 1000 years, and its some characteristics are the change of landforms rate, high change of landforms. So landforms change rate are high. Found steady state equilibrium. The conditions is steady state equilibrium conditions. In geomorphology of equilibrium is a very important concept, and graded time scale support the steady state equilibrium conditions. And example is coastal landform formations. So its important example is coastal landform formations. Coastal landform formations, we in geomorphology we all know the coastal landforms. So its evolutions and its formations is mainly support the graded time geomorphological time scale or temporal scale. And another or last temporal scale subdivision is steady time. So its resolutions level is micro and time span is 10 years, about 10 years. And the some important characteristics are landforms developed or evaluated in very short time span. Rapid change of landforms is very rapid. The landform change is very quickly. And dynamic equilibrium, its conditions, the equilibrium conditions is dynamic. So it is always changeable conditions. Dynamic means it is always changeable. The landforms are always changeable within times, within micro times. means very short times. And its examples are wind landforms formations. So the wind landform means the Aeolian landform formations is basically the best example of best example of steady time scale in temporal scale. And here we represents the diagram, three diagram of cyclic time, graded time, and steady time. So in y-axis we represents the channel, and in x-axis the time. So first is in cyclic time, then is in graded time, and another is steady time. And now we know about what is spatial scale. Spatial scale refers to the order of magnitude of extents or size of landforms area or geographical distance studies, or describe the study of landforms and geomorphic processes with varying few points objectives. So the spatial scales is scales or unit through which we can study the landforms on the basis of their size. Size means the landforms it's small, medium, or large shape, through which we can study the landforms and its evolutions. Spatial scales also are three types. One is microspatial scale, another is mesospatial scale, and last is macrospatial scale. First is microspatial scale. Microspatial scales length, how much area or length the landforms covered. So first is length, 1 meter to 1 km. Area, 1 meter square to 1 km square. External and internal factor which control the landform evolutions. First is climatic factor, earthquake, volcanisms, etc. Descriptions, it is local. In example is punch pole, example which developed in microspatial scale. Very short range, the area is covered very short, very small area covered by the landforms. Second is mesospatial scale, 1 km to 100 km, and its area about 1 km square to 10,000 km square. And its external and internal factors are climatic factor also include, and another is isostatic change. Isostatic means the stability or instability conditions change in times. And description is, it is regional, local. Microspatial scale is local in descriptions, and mesospatial scale is regional, and its example is river meander. So river meander formations, it is an example of mesospatial scale. So it covers the area about 1 km square to 10,000 km square, and its length about 1 km to 100 km. So it is some characteristics of mesospatial scale. And last is the macrospatial scale, which length about 100 km square, greater than 100 km square, and its area covered by 10,000 km square. And it's also some important external or internal factor which control the landforms and its development. First is climatic factor, second is landslide, and another is earth movement. And its description, it is a global process. And its description is global, large floodplain, and its best example is large floodplain. It is an extensive large floodplain is its best example of macrospatial scale. Therefore these are two types of geomorphological scale. One is time or temporal scale, and another is spatial scale. Now we know the importance of geomorphological scale. So first one is Geomorphological scale are much significant to study the evolutions of landforms and its development. Second is to study the equilibrium in geomorphology. Geomorphological scale are important concept or most important method to study the equilibrium in geomorphology. Equilibrium means a static conditions of landforms and its origin. Static means stable conditions. And to show the relationship of different types of landform, geomorphological scale also very important aspect. To show the relationship between the landforms, the geomorphological scales are very important concept in geomorphology. So these are the main two types of geomorphological scale. I hope you understand the concept of geomorphological scale.